is yet another lesson. Let me link the slides. Let me post it on Discord as well, so that everyone knows. Twitter. Okay. Nonsense. Okay, let's wait for people to gather. Good evening, Roloff. Indeed. Okay. Let's wait a few minutes until we start. Hello, Catgirl Aurora. Please check your pull requests because they have remarks at them, old ones of the previous chapter. Hello, Mikhail. Thanks for the suggestion about changing the theme for slides. It seems that indeed black is a better background color than white. I think the contrast is better. I also didn't think I like it, but I think I like it. Okay, let's wait a few more minutes and we'll start. Let's go. So, lesson 3, abstract and virtual. Today we'll learn what virtual methods are, we'll learn about polymorphism and about abstract class and abstract methods. So let's get to it. Let's start from an example. Oh no, animations. So the example, I'll have it this way. We have 3 classes: teacher, good teacher, and bad teacher. Teacher works, so he has method work. So teacher has method work, a good teacher has method work, and bad teacher also has method work. So they all do the same thing, but they all do that thing differently. When you look at the teacher, teacher just does teaching. When you look at good teacher is learning with my students. And when you look at bad teacher doesn't let students ask questions, and he is presuming that he is superior to everyone. So you have 3 teacher classes all doing the same thing but differently. And key points here are that work is a virtual method, and each child class overrides the virtual method so that it can do its own implementation. And I was supposed to show the other part. So if we create a new teacher, a good teacher and a bad teacher, and say work, you'll see that they print each their own thing. Let's carry on. Imagine there was one more teacher, superb teacher. And again, when moving slides from one theme to another, I forgot to include it. So give me half a minute so that I get it back to you. Just a moment. Right, it's hidden. Okay. So this is superb teacher. Superb teacher does everything that good teacher does, but he also prepares extra material, specializes for students, and he's simply loving his job. And the cool thing about this example is that it calls good teachers method from the overridden same method. So it does the work twice, but it adds something extra when it does when superb teacher does his work. So the end result is that it prints everything that good teacher printed, but its own stuff as well. All right, let's continue. So let's talk about how could we achieve this and what happened. So virtual is a keyword meaning that method is not final and that implementation can be changed in a child. So, and we changed implementation using override keyword. So if we take a look at, again some code. So if we take a look at the refactored version of teachers, we can see, what can we see? We can see that we created teachers array with all the 4 kinds of teachers. So before we had them created one by one, and then we called work of each teacher one by one. But now we create 4 teachers, store them in the teachers array, and we loop through all the teachers and say to them work. And this, what you can see, is polymorphism. Teacher work is polymorphism. It's polymorphism because this var doesn't change dynamically to teacher, good teacher, bad teacher, superb teacher. It always remains teacher. So we call base type teacher work, and based on initially what the teacher was created as good teacher, as bad teacher, as superb teacher, as just teacher, will have its own specific behavior. So you can see that the output is again the exactly same. And this thing is called polymorphism. It simply means that different things, more like the same thing is being called from multiple classes. So the same thing of a base class is called from multiple classes which provide its own implementation. So let's say an animal has method talk, and each animal talks in its own way. Goose quacks, bear growls, snake hisses, dog woof woofs, barks. So that's polymorphism. Calling method of a base type and getting implementation from child types. That's polymorphism. So calling the same method from child but taking child's implementation, or implementation of a class which implements something of higher level. And now let's talk about abstract. So we have two personalities. So first we have personality. Personality has a name and it has a method called print status. And then we have two personalities, pessimist and optimist. So when pessimist prints its status, it's very dark, gloomy, and not very nice. And when optimist prints its status, it's very happy, nice, and positive. And again, identically, when we call pessimist print status or optimist print status, will have their own implementations called and not something else. So very similar to virtual, but slightly different. So abstract is very similar to virtual, but it also, the keyword also applies to class level. So classes can be abstract. Classes cannot be virtual, but classes can be abstract. And methods can be abstract. Virtual keyword applies only to methods. Abstract keyword applies to both methods and classes. So what does it mean? For abstract class, it means that it cannot be instantiated. It means that class is abstract, and in most cases it will be lacking something. Some implementation will be abstract, which means it needs to be implemented in a child class, but it doesn't have to be that way. So abstract method is a method that has to be implemented somewhere if you want to instantiate that class. So it's a method that needs implementation. That's abstract method. So in my case, I had public abstract void print status in parent. So that's the method that I need to implement. And again, I implement it using override keyword. So public override void print status will print the status, will implement how status should be printed in a child in pessimist or optimist classes. Just one thing to note, for virtual methods, I have default implementations that I can change, but for abstract methods, I have no implementation. I'm forced to implement it eventually in child classes. So to summarize, in general, try to avoid virtual methods. By the way, abstract is also a virtual method, a kind of virtual method, but a bit more constrained. So avoid making methods that you can override. you should avoid them, because if you don't, there's nothing preventing from just completely making a mess out of your program. If I see that a person can talk, but the method is virtual, I can no longer trust that the person will talk in a child class as well. Probably it will, but it doesn't have to be that way. And that is a scary thing about virtual methods, that they can change their behavior in such way that it no longer even makes sense and is based on their name and their class. So be careful. If you do decide to override something, preferably do it with abstract methods, because abstract methods must be implemented elsewhere in child classes, so you don't really negate behavior. There is no behavior in the first place in the parent, so it's not as bad as virtual. But there are, of course, use cases when it should be done, so don't be afraid to use it when it feels natural, and when you really have good justification of when it should be used. And in the next lesson, we'll be learning about interface. So, yeah. Now about questions. So, again, please write first, do you have any questions? And I'll answer Aurora's question. Can you override a virtual method with another virtual method? Yes, but that I mean, when you override methods, they I don't know, I don't remember if you can override abstract methods infinitely, but I know that you can override virtual methods infinitely. And saying with another virtual method doesn't really make sense, because the method remains virtual after it's overridden. So if let's say we have classes A, B, and C, and B inherits A and C inherits B, and all classes, well, you override method foo in all those classes except A, then you can override it in both B and C, in child and in grandchild. Yes, it is. It doesn't change. You can keep on overriding. Can you override any method? Yes, you can override any method that is virtual or abstract. So I guess no, you cannot override any method. Only virtual and abstract methods can be overridden. So now, guys, please write down one thing that you think you understood well and one thing that you would like to learn better. Yes, sealed is a keyword which says you can no longer override, you can no longer inherit. And here's the example. So for infinite, or at least 3-level override, so teacher had method work, good teacher had method work which it overrid from teacher, and superb teacher had method work which it overrid from good teacher. So good teacher overrid work once, and superb teacher is the second override of work method. It's still virtual, yes. This is still a virtual method and I can override it. Can I override again abstract methods? Let's try it. I don't remember. Very more like sad optimist. Optimist. Public. Doesn't matter. I don't need that. Print status. Public override. Yeah, sure, I can. Of course. So it's the same thing again, I can override. So basically overriding abstract method, the second time it becomes exactly like virtual method. So yeah. Let's explore those examples then, shall we? First from abstract. So we have pessimist and optimist, print status, and we also want to have set optimist. And we say that set optimist will print his own status. Let's put a breakpoint there. Let's debug our application and let's see what happens. We see that we got sad printed and a conflicted state that said, "What a beautiful day, my friend." So it did what we expected. We basically managed to override it, providing extra behavior and doing something on top. I think an interesting thing would be to explore the sequence construction of those objects happen. So and I think it's pretty natural, you know, that you first create the topmost thing so that you can go into details later on. So let's go back. So let's do this as a proof how it works. Now I have a question to you guys. Why is a constructor of personality protected? Why do we have a protected and not public constructor for an abstract class? Anyone to answer? Yeah, so it doesn't make sense to have public constructor for abstract class because it will never be created directly publicly. So we might as well just have it protected, which is only useful for child class. Exactly. Good. Well said. Anyways, let's omit this. And let's just see what happens when we create set optimist. So when I created set optimist, you can see the order of constructors that were called. So we start from the highest level constructor, and the lower we get, the lower level the constructor gets called. So we can see that first the abstract class constructor got called, then optimist, and then a special case of optimist constructor was called. So if you are initializing something, you should be aware that obviously you cannot use something of that personality that optimist might initialize within personality. You shouldn't even expect that to exist in personality. So it's quite obvious that they'll be in this way. So let's do this as a personality example. Personality example, and this one will be teacher's example. All right, refactor. So in teacher's example, it's more interesting. As I mentioned, we have a teacher's array, and we loop each teacher, and we do work with each teacher. And what will happen is that this is actually a teacher. So essentially we say that, hey teacher, do work. And if we look at teacher, we might be expecting, oh, it will be teaching. But no, it will not be teaching because we override the behavior in a specific teacher class. So if we run the demo now, you can see that each teacher teaches in its own way. Can you have an array of abstract classes too? Of course you can. It's absolutely no different than the other one. So we don't really need this. We can say var personalities, and I can make this, whoops, I can make this explicit and be quite simple. Personalities T. So this and this. And again, for each personalities, personality. Yes, I say personality, print status, personality, get name. Okay, sure. And if I run this now, wrong example, personality example is what we want. So if I run this now, you can see oh, right, get name needs to be printed. Give me a second. So you can see that pessimist said today sucks, optimist said what a beautiful day, and another kind of optimist said, which was sad optimist, said sad before he said anything. Again, in a loop, polymorphism. So it's very fluent, this kind of thing, and therefore it's that important in object-oriented programming. It makes our program flow fluent. We don't need to do an if statement to see what kind of personality we have. We can just have a linear flow and a nice, smooth code. One of the pitfalls when working with virtual methods, let's go back to virtual methods, is the fact that you might forget that you are working with virtual methods and that you actually have a method which can be overridden, but you don't override it and you just repeat it. So what if you have a mysterious teacher class which will do work? You see, the crazy thing is that it will compile. So you might think, hey, what the hell? I just duplicated my method in a child class. Actually, of course, that will compile. But you see, it's just a warning. So if I compile this, it compiles. If I create this and try to see what happens, let's see what happens. Private, static. The overshadowing is obvious, but there's one interesting thing about it. So we create a mysterious teacher. We say that it works. And when we run this demo, we'll see that it does what we expect it to do, which is mysteriously teaching. However, if we create side by other teachers and do work with them, or specifically all I care is this teacher and this teacher, let's see what happens now. What's wrong? This is not needed, right? So now what do you think will happen? We have a teacher and we have mysterious teacher, and we call their teach method. What do you expect mysterious teacher will print? Will it print mysteriously teaching, or will it print teaching twice? Will it print teaching and then mysteriously teaching, or will it print teaching twice? What do you guys think? Yeah. So if we run the demo, we see it prints teaching twice, even though we had this method. And it prints it simply because we didn't override it. And if we didn't override it, it just gets shadowed and it loses the link with the teacher class in terms of the method work. Now, this method work becomes unique to this class and has no link to the teacher. Therefore, it gets ignored, and therefore this gets called when doing for each loop. And if I override, it will do the mysteriously teaching again. So yeah, I think that's pretty much all that I wanted to show in terms of code. Do you have any questions? So one more thing about virtual methods. Here you can see that I can do extra something on top. So I can call base implementation and add some extra behavior on top. But again, it's quite simple. So without further ado, let's move on to Kahoot. So this is the Kahoot. For those who don't know, go to this link. And this is the code. Ooh, we can change music. What music do you guys want? Okay, let's wait for others still. It's annoying. Music is annoying as well for me. But I'm curious to explore. Still waiting. Okay, seems everyone is there. Let's start. Abstract and virtual. 11 questions. Let's see. So, keyword virtual is applicable to which of the following? Yes, it's only for methods. Let's continue. Oh, they updated. Okay. Keyword abstract is not applicable to which one? Not applicable. Yeah, it's not applicable to field because class can be abstract and method can be abstract. And Aurora number 1, Mihail second, and Resho catching up. What methods can you override? Yes, so both answers are correct. Static, of course, you cannot override. Yeah, the thing about Kahoot is that I cannot mark that you have to check both, so either is fine. What similarity does abstract and static have on a class? So it has nothing to do with polymorphism because static class cannot have child classes, so you cannot inherit static, so polymorphism is not an option. But definitely you cannot instantiate the static since it's one for all, and you cannot instantiate abstract because it needs implementation from a child or inherit. So cat girl number 1, Russia, close by. True or false? Must you always override virtual method? No, you don't have to override it, so it's fine. It's default implementation. You can stay as it is. Polymorphism is when parent inherits child, child inherits parent, The same type calls two different methods using parent type. Different types call the same parent methods using parent type. Yeah, so the answer is this one. It's not this one because you need to call the same method using the parent type, not two different methods using the parent type. And first one, parent inherits child, that doesn't make it polymorphic. That's not enough, so you cannot say that it's polymorphism. And this one is just completely incorrect. Ratio number 1. When should virtual method be used? So when we want to provide default implementation and at the same time we want to override it, potentially sometime, we should be using virtual methods, virtual keyword. Ratio seems to be in the lead. Does it make sense to make public constructor an abstract class? Well done. It doesn't. Next. Is it possible to call base implementation of an overridden method? And the answer is yes, it is, of course. Can abstract methods contain a body? They cannot, and if you are thinking that after you override it does contain a body, well, at that point it's no longer abstract. At that point it's pretty much virtual. So abstract doesn't have a body. Abstract method, I mean. If you create an instance of strong and then call test, what will be printed? So you have an example with two classes, man and strong. Strong inherits man and overrides the test method of a man class, where it prints strong. What will be printed? Man, strong, strong man, or man strong? Well done. And this is a good sign to me that you all understood the lesson well. Resho came back again as number 1. Royalov number 4. Aurora number 2. And XD number 3. Good job. And the homework. The homework is already in the homework channel. It's very simple. It's very simple. All you have to do is to apply what you learned and simulate 2 factories. Factories assemble computers, and there is a factor. And when you assemble computer, you know what steps you need to do. You know that in both factories you need to add RAM, CPU, GPU, motherboard, hard disk, and other stuff. And the same goes in both factories, except that different factories have different pieces they need to add. So you need to implement the assemble method and polymorphically call both factories to assemble computers from them. So I think it's an interesting yet simple homework, and I wish you good luck doing it. So that's it that I had for this lesson. Do you have any more questions? And if we don't have any more questions, we can end early today. So thank you all for your attention, and see you next time. On Saturday, we will be learning about interfaces. See you there.